So today we're going to simplify these rational functions and state restrictions. Essentially here we're going to be doing division of these rational functions. So the very first thing you want to do when you have a question like this is to factor every single numerator and denominator that you possibly can. So for example, I noticed that I can factor this first numerator here. I can common factor out 6x from this, and this becomes 6x. Zoom in a little bit, 6x times x minus 2 over 2x. And then I can also factor the numerator in my second rational expression here as well. I'm going to start by just common factoring out the 3 in this step here, like that. Now this still isn't fully factored. I realize that we can probably factor x squared minus 4x plus 3 further. I need to find two numbers that multiply to 3 and add to negative 4. Those numbers, of course, would be negative 3 and negative 1, since they multiply to 3 but add to negative 4. So on my next line, I'll put 3 times x minus 1 times x minus 3 like that. And then everything else I'm just going to repeat. Okay, now once everything's fully factored, the next step is to keep, switch, flip. So we're going to keep the first fraction the same as it is currently. Then we're going to switch the division sign to a multiplication sign, and then we're going to flip the second fraction. So to do that, we'll keep this one the same. We'll switch this to multiplication, and we'll flip this like that. Okay, and now we're going to cancel out anything that we are able to. So I'm going to factor out, or sorry, I'm going to cancel out x minus 3 and x minus 3. I'm also going to cancel out 2 times 3 makes 6. So I'm going to cancel the 2 and the 3 out with the 6. I'm also going to cancel this x with this x. And so this leaves us with x minus 2 over x minus 1. And that's our final answer. The only other thing we have to do, though, is state the restrictions. So when do restrictions occur? Really quick, restrictions occur when we have a 0, a value that would lead to us having a 0 in any denominator. So it could be this term here, or this term here, or this term here, because these terms here, the 3x squared minus 12x plus 9, that is going to end up being a denominator when we flip, right? And so what I always tell people is to find out the restrictions from the step right before you flip and the step once you have flipped. So we're going to look at this step first and look at the denominators and determine the restrictions from here. So restrictions here would be x cannot equal to 0, otherwise 2x is equal to 0, and we have 0 in our denominator, which we can't have. Or for the x minus 3 one, that means that x cannot equal to 3, otherwise that second fraction would have a denominator of 0. So that's all for that one. Now I'm going to take a look at this next line here. And for this next line here, I notice that we also have that x cannot equal to 1. If x is equal to 1, then we have a 0 in the denominator of our second one as well. Now, even though some of these things like x minus 3 and the x in the denominator do get canceled out by the end, because they were in a denominator at some point, we still have to write restrictions for them, because essentially we're writing restrictions for the original expression, not just for what it's simplified to. Because essentially what we're saying here is that this original question simplifies to x minus 2 over x minus 1, with the understanding that x can't be any of these values, because if it was, we would actually get something undefined if we were to plug back into our original. So that's the way to think about it there. All right, well, without further ado, let's move on to our second and final question for this video. So first things first, what do we do first? We factor everything we possibly can first. And I noticed that we can factor both numerators. This first numerator, I'm going to start by common factoring out 8x from. So we're going to get x squared minus 2, like that. Okay. Then for the next one, I'm going to common factor out a 2. So we're going to get 2 times x squared minus 9, like that. The x squared minus 2, we actually can't factor further because 2 is not a perfect square. So we would end up, if we were to try to factor it further, getting like square root of 2 plus and minus square root of 2. However, x squared minus 9 is a difference of squares, so I am going to further factor that one. I'm going to just write everything else out, and I will factor the x squared minus 9 into x minus 3 times x plus 3. Now, for anyone who's wondering, how did I do that? That's with the difference of squares formula. So recall that a squared minus b squared is equal to a minus b times a plus b, like that. And there we go. Okay, now let's continue. So our next step is going to be to do the flipping step. We're going to keep the first fraction the same. And then we're going to switch the division sign to a multiplication sign. And then we're going to flip the second fraction. Now we're going to cancel some stuff out. So the 4 and the 4 times 2 makes 8, so that cancels out with the 8 in the numerator. X and x cancel out, and x minus 3 and x minus 3 cancel out. So we're left with just x squared minus 2 over x plus 3, and that is the final answer. Final answer right there. Okay, now I need to state the restrictions. So the restrictions, starting with restrictions in the step right before we flip, we have that x cannot equal to 0 and x cannot equal to 3 because either one of those would make one of the values in one of these denominators into 0. And then we also want to check the step after we did the flip because now we have a new denominator in the second fraction. And in this case, this also adds the restriction that x cannot equal to negative 3 either, because notice over here we have an x plus 3 in our denominator, meaning that if x was negative 3, we end up with a 0 in our denominator. All right, well, that's it for this video. Please feel free to put any questions you have in the comment section, and we'll see you for the next one.